Dear students, in our previous lectures we discussed structures of pyrrole, thiophene and furan, and we came to know that they are aromatic compounds. In today's lecture we will discuss the relative aromatic character of these three compounds. We will see which out of these is more aromatic and which is less aromatic, and we will compare their resonating aromatic character with the benzene. So first let us talk about benzene. We all know that benzene is an aromatic compound, and it can be represented by, it has two resonance hybrid structures. These two resonating structures and the resonance hybrid, it can be represented like this. Now the one thing from this structure is clear, that benzene has structure 1 and structure 2 resonating structures that contribute towards resonance hybrid, and these two structures, they are of equal stability. They are of equal stability because they do not involve any charge separation. So one thing to know, that benzene, the structure of benzene is a resonance hybrid of two resonating structures of equal stability. Now I will just write resonance structure of only one heterocyclic compounds, because the resonating structures, they are same. All the three resonating structures you can see from our previous lecture, we draw them, they were same. So we are talking about five membered aromatic heterocyclic compounds. So I will choose any one. Let me say I have chosen pyrrole. So I will write a resonating structure of pyrrole very quickly, because I will just write only one of three the compounds that we have to discuss today, because they also have same resonating structures. Okay, positive, negative. Actually there is no need to write more resonating structures, so and so on. The this thing will go on like this. And H, so here comes the negative charge. Now it comes here, here is the positive charge. So this is the next resonating structure, double bond, positive, negative. This, now this comes here, this comes here, this is the next resonating structures. So now we have written these resonating structures so many times of these five membered aromatic heterocyclic compounds. You can now you should not now do any mistake while writing the resonating structure. Now you can see in these resonating structures, there is only one structure which does not involve any separation of charges. All these structures, they have separation of charges, so they are quite less stable. So towards this resonance hybrid structure, this structure has only one structure has highest contribution, whereas in case of benzene there were two structures of equal stability. So that is why these five membered heterocyclic aromatic heterocyclic compounds, they their aromatic character is lesser than benzene. So aromatic character of five membered aromatic heterocyclic compounds, which are pyrrole, thiophene and furan, it is less compared to benzene. So one thing is clear, all these three five membered heterocyclic compounds, they are less aromatic than benzene, and the reason I have already told you, that because of out of these five resonating structures, 1 2 3 4 5, only one structure is that which does not involve any charge separation. This structure, all other structures, they have separation of charges, and it makes major contribution towards the resonance hybrid, whereas in case of benzene there are two structures of equal stability that make contribution towards resonance hybrid. That's why these five membered heterocyclic compounds, they are less aromatic than benzene. Now if we have to compare the relative aromaticity of these five membered rings, which is pyrrole. First I will write their structure, and this is your thiophene, and this is your, so this is furan, sorry, this is thiophene, so this is pyrrole, this is furan, this is thiophene. So now the structure is already clear. Out of these two electron pair, only one electron pair is utilized in resonance, other remains in sp2 hybrid orbitals. Now these compounds will be aromatic if these electron pair on these heteroatoms, they participate in resonance. Only then they become, they have 6 pi electrons and they are aromatic. Now in the compound in which these electrons participate in resonance, which has higher participation in resonance, that will be more stable. So now if we compare the electronegativity, then oxygen has highest electronegativity, then nitrogen, then sulfur. That means oxygen will prefer to keep its electrons towards itself, so it will not readily donate electrons towards resonance, whereas sulfur being least electronegative, it will donate its electrons towards resonance easily. So that means the electron pair on oxygen is least involved in resonance, whereas in case of sulfur it is mostly it participate mostly in resonance. So that's why the aromatic reactor will be thiophene, should be more uh, aromatic than pyrrole, and which should be more aromatic than furan. So this is the relative aromatic reactor of these compounds, and this is explained on the basis of electron negativity of the heteroatom. Oxygen has highest electron negativity, so its tendency to donate its electron pair towards resonance is quite less. Sulfur has the least electronegativity, so it can easily donate its electron pair which are present in, this electron pair is present in, you have to remember, unhybridized p orbital that we have discussed in their structure. So that's why this thiophene is most electronegative and furan is least aromatic, sorry, not electronegative, aromatic. This is your relative aromatic character, and benzene is most. So this is most aromatic is benzene, then thiophene, then pyrrole, and then furan. So that is all for this lecture. So thank you very much for your kind attention. So in our next lecture I will discuss in detail about pyrrole, how they are formed and what are their chemical properties, that we will discuss in our next lecture. We will discuss the proper synthesis and chemical properties of pyrrole. Thank you very much.